Okay, so we have a new problem here. It's another statics problem. We have the ground here, and flat ground, and we have a statue with a base some statue perhaps, and it has a base, although it doesn't look symmetrical, it's supposed to be. And we're going to push this statue with a force from the side. A child is going to push it. And what we want to know is whether or not this statue is going to fall over or if it's going to slide. Now, how are we going to do this? Well, we need some information first. Number one, what is the mass of the statue? And the mass of the statue is going to be equal to 12.2 kilos. Okay? And also, we know that the child is pushing the statue at a height of 70 centimeters above the ground. So this distance here, where the force is being applied, is 70 centimeters above the ground. In addition, we know that the coefficient of friction on the ground is going to be equal to 0.26. Now, in addition to that, what we need to know is, well, I think that's about all we're going to need to know at this point. Oh, no, not quite. One more piece of information, and that is the base of this statue, okay, has a length of 12 centimeters. Now, is it going to fall? So let's draw it again. I don't really like this drawing up here. Let's kind of draw it again. And the way we can draw it is we can just draw it like this. Now, what we want to know, and let me draw the forces in a different color here. Here is a force. And where else is there going to be a force? Well, there's also going to be a force here, up. Now, if you realize something, that in fact, what's the difference between tipping versus moving? Well, if it tips, the summation of the torques is not going to be equal 0. If it moves, then the summation of the torques is going to be equal to 0. Okay? Because when something tips, it rotates. And which point is it going to rotate about? Well, it's going to rotate about this point right here. Okay? There's one more force which I didn't draw, and I should do that in red. And that is right here. Oops. Let me undo that, actually, because I didn't really draw it in the right direction. There's a force right here that's going to be going straight down, and that's going to be the force of gravity. Okay? And this is going to be the force of the ground. And of course, you realize there is going to be, this is ground Y, and of course we do realize there's going to be one more force, like this, and that is going to be ground X. And this is going to be the applied force. Now, in order to determine if it's going to tip, what we need to do is we need to say, if you push it, is it going to tip? But also, what we also need to know is what's going to make it move? Because if it's moving, then how hard do we have to push with? So in other words, the horizontal force for it to move has to at least be equal to friction for it to move. Okay? So if I say, okay, summation of the x forces must equal 0, summation of the y forces must equal 0, that's true. But this one in particular, that's how we're going to figure out what this has to be. So we're going to say for x, F applied, that's positive because it's to the right, minus FGX, that's got to be equal to 0. That's the, at least F applied has to equal FGY. Sorry, FGX. Now, that means, what's FGX? Well, FGX is the force of friction. And what's the force of friction? That's equal to mu Fn. But what's Fn? Fn is the normal force at that location, which is mu FGY. Now, if we now take a look at this and say, aha, the only two forces are mg and FGY, you can easily see that FGY is going to have to equal mg. Therefore, that's going to be mu mg. Okay? So look at my graduation of logic here. The applied force has to be equal to the other horizontal force, right? Horizontal, horizontal. That horizontal force FGX has to be equal to the friction force, which is mu Fn, which is mu FGY, which is mu mg. Therefore, the applied force has to be mu mg. Now, if that's the case, that's the minimum force for it to move. Is that force going to make it tip, yes or no? Well, we need to take the summation of the torques about a certain point. And the point I'm going to pick is right here again, at G. Let's call that point G. Hence, if I now do the summation of the torques about point G, if it is equal to 0, it moves. If it's not equal to 0, it will tip. So, how do we know what this is? Well, about this point, there are only two forces. One is applied, and you can say that it acts right there, applied. And the other one is mg, which you can say it acts here. So now I know both distances. One of the distances is 70, right? So about this point here, one distance is 12, and one distance is 70. This one happens to be clockwise, which is negative. This one happens to be counterclockwise, which is positive. So let's do the positive one first. So let's go positive. So now I'm doing this. mg times 12 centimeters. By the way, I should write that as meters. Let's get rid of that. And so that's just simply 0.12 meters. Now that's a positive. And then minus applied force, which is, of course, we know mu mg, times 0.70 centimeters. And let's see what's that all equal to. Let's see if it's positive or negative. I'm not sure. The m is going to be, what was the m of this thing? 12.2 kilos. Let's go back. So 12.2 times 9.8 times 0.12 minus mu, which was 0.26 times m, which was 12.2 times g, which is 9.8 times 0.7. Get our trusty RPN calculator, and we're almost done. Let's go 12.2, enter 9.8 times 0.12 times, and then we go 0.26, enter 12.2 times, 9.8 times, 0.7 times, minus. And we get an answer of negative 7.4. Question, negative 7.4. Now, by the way, that's going to be a torque, so it's going to be Newton meters. Is negative 7.4 going to cause it to rotate? What is a negative torque? Is that positive, or is that clockwise or counterclockwise? Clockwise, remember, is negative, and counterclockwise is positive. Therefore, negative 7.4 is definitely in this fashion, and sure enough, the answer is tipping. The lamp is, or the statue is going to tip. So, there you go. Hope you enjoyed it. It will tip. Thanks for watching.